Hello, I'm Kurt Hillier with NXP Semiconductors. Welcome to Embedded World 2024. Today I would like to introduce the NXP Cloud Studio with a specific focus on the contributions from the MathWorks. So let's go ahead and take you in here and give you some of the value propositions on why we're doing this and how MathWorks is contributing to our ecosystem that's so important for our customers. So we'll talk first about Cloud Studio. Why is NXP, a semiconductor company, working with software and cloud? Let's take you there. We want to be able to have customers start early, and that's by providing a high quality ecosystem, virtual models provided by Synopsis that allow them to start writing software, building their Hill environments, getting MATLAB and Simulink working in these environments ahead of silicon. So you don't have to wait on your EDBs or your B samples. You can start doing prototyping early in the system by getting all of your tools and your virtual SoCs running early. We want to provide scale. By doing this in the cloud, you can have more users up to speed more quickly. They don't have to install all of these complex tools on their own laptops. We create cloud environments that have the tooling, the MathWorks environments, Design Studio from NXP, as well as the Synopsis virtualizer, all in the same environment as a persona. Then you can use that persona to copy it out to your teams. Everything can be pre-installed. It's all about speed. We want you as an OEM or a tier one to hit the market quickly. We don't want you bogged down with tooling issues, with porting issues, with bugs that really don't have anything to do with the operation of the ECU or the vehicle that you're creating. So this is all about streamlining the environments to get you to market quickly. Finally, the vehicles today need to be updated over their lives. You can use model-based design to gather data from your vehicle, send it into the cloud environment in a data lake, and have your MATLAB and Simulink tools running such that you take this data, you compare it against your models, you can actually inform your models over time and have them be high quality for the life of the vehicle. So that's another use case that we talk about. We have a number of partners that are contributing. We'll highlight AWS, Synopsis, but MathWorks will be the center of this particular talk. So we shift left, we stretch right, high quality systems that allow you to get to market quickly through the life of the vehicle. Here's this ecosystem I talk about with data coming from the vehicle, going to a data lake, and then using the tools that you care about to do continuous integration and continuous delivery or deployment. The MathWorks is looking at cloud enablement as well. We will be partnering with them in the future. We do have a cloud DevOps proof of concept that we produced back in 2022. So we've been looking into this area for a couple of years now. So you take that code, you test it, you validate it, you check it daily, you put it through your release pipeline, you test it in the field, you go through your hardware in the loop testing, you got the quality that you need, you push it to the vehicle, and then the whole cycle repeats. It's a life cycle for the vehicle algorithms and the data that we're creating. So let's take a look at the instance, and we'll take a look at the MathWorks in operation, and then we'll finish up the video for today. So we created, with our partners, an Amazon machine image running in the NXP virtual private cloud that's in the AWS public infrastructure. So that AMI has a Windows operating system that becomes resident when you start the machine. And we have pre-populated the S32 Design Studio and the Synopsis VDK. In future versions of this, with a model-based design persona, the MathWorks tools can also be created in a cloud environment. You can do your model-based design, take your images, your C code and your .h code, put those into an NXP workflow and get your object files. So that will be future work that's to come. And again, that's a model-based design persona that's cloud enabled. The nice thing is the tools are installed ahead of time and you don't have to do the download and the installation process yourself. It saves you time. Let's go into a little bit of the operation on this demo. This is the MathWorks Simulink environment. This is a pre-built example. Another powerful technology that the MathWorks folks put together are pre-built examples for systems that you care about. Maybe it's financial, radar, model predictive control, hybrid electric vehicle, the powertrain block set, the vehicle dynamics block set. MathWorks has a lot of strength in building the pre-built examples that help you get started quickly. From the NXP side, we create a model-based design toolbox, which is an add-on that goes into MATLAB and Simulink, so that when you use the MathWorks embedded coder technology, that code is passed to the model-based design toolbox, MBDT, provided by NXP, and that allows you to take that code and run it seamlessly on your NXP hardware. This is a real valuable technology. It takes you from model to execution quickly and easily. So we generate .c and .h. I'm going to show you a bare metal example, okay, where we have our cloud instances, we have the IDE, the .c and the .h code from the code gen is going to be populated into the IDE. We build with GCC to get an object file, and then we test it on the Synopsis virtualizer. So let's walk through that, and then we'll wrap up. So here we have the two IDEs. This is all the MathWorks generated code for adaptive equivalent consumption minimization strategy. So there'll be a quiz on that later. That is created by Kevin Oshiro and Dr. Simona Inori from Stanford, as well as I think Dr. Giorgio Rizzoni from the Ohio State University. There's a nice book on this. There's an algorithm. It is a cost minimization algorithm. So you have two disparate plants, motor, combustion. They have different torque profiles. You do a P total, a power total, and then you pick the minimum operating point every 20 milliseconds. It's a very sophisticated algorithm. You code gen it, and then it runs on the S32 products out of the box. So that's the code. We're going to execute it every 20 milliseconds. We get optimal motor torque and optimal engine torque. Let's take a look at that. We're going to take that L file, put it into the virtual SoC, again, running in the cloud, looks like a real chip, and we get our torque values coming out. We get motor torque and engine torque. In some cases, you'll see the motor torque is negative. That means that the system is regenerating the battery to boost the state of charge of the battery pack. So it's all in operation, all in the cloud. The value, again, of doing this is pre-configuring these environments so they can go to your development teams, whether they're human developers working with UIs or automated test regression developers doing DevOps pipelines. Either type of interface can be supported in these. It's all, again, about let's get this done fast and make it easy. Finally, we're going to talk about environmental parity. One of the values that Synopsis provides is a high quality virtual SoC that will match the behavior of the physical SoC from a functional software perspective. And so you can see the same MathWorks code was operational in the cloud on a virtual SoC, and it was operational on a physical EVB. And the value we provide is to make sure that the operation in that virtual SoC is matching the operation in the physical SoC. So that completes our exercise. Again, a big thanks to the MathWorks for all the work that they do to collaborate with us to get really valuable systems and solutions to our customers in the market. Stay tuned, there's more to come. We'll be happy to talk with you at upcoming events or reach out to your sales or your FAE contacts, and we can talk more about your applications, your pain points, and how we can make life better for you. Thank you.